In this module, we're going to discuss continuous integration and continuous deployment, and the two Microsoft tools that enable it, Azure DevOps and GitHub. First of all, DevOps is a set of practices that combines software development and IT operations. The goals of DevOps are to shorten development cycles and provide continuous delivery with high-quality software. It involves a lot of workflow automation in order to enable these goals. Continuous integration, or CI, allows team members to merge their code and integrate changes faster. When there are conflicts, tools can assist developers with making decisions. And integration can be done without breaking the software, or at least problems can be found and resolved faster. Automation allows you to run all sorts of tests on the code and perform automated builds on the central repository, so you can ensure that code checked in is of high quality. The CD in CI/CD refers to continuous delivery and/or continuous deployment. They sometimes get used interchangeably, but they have different purposes. Continuous delivery usually means that code changes are automatically tested and uploaded to a repository, where they can then be deployed to a live production environment by the operations team. Continuous deployment refers to automatically deploying the code from the repository to production, where it can be used by customers. So it removes the manual processes that slow down app delivery. Now let's talk about the tooling. Azure DevOps provides a set of tools for collaboration and automation. Azure Repos is for centralized source control of your code, using either Git version control or Team Foundation Server version control. Azure DevOps has Azure Boards for planning and tracking work, and Azure Pipelines, which is the build and release service that supports continuous integration and continuous delivery. GitHub is actually a similar service that also provides centralized source control for your code in Git repositories. It also has some capabilities for planning and tracking work, and it has a service similar to Azure Pipelines called GitHub Actions. A lot of Microsoft documentation focuses on GitHub integration, and that's because Microsoft acquired GitHub in 2018 as part of their focus on open source development. So while Azure DevOps is still an important service, there's now a focus on both. And Azure DevOps even allows you to keep your code in GitHub and pull it into Azure Pipelines for building and deploying. You'll see that option when we create an Azure pipeline later in this module. GitHub Actions and Azure Pipelines both allow you to build your code on virtual machines provided by the service. In GitHub, these are called runners, and in Azure Pipelines, they're called agents. These virtual machines have software pre-installed, and you can also install anything you need on them during the run of your GitHub Actions workflow or your Azure pipeline. Both services use a language called YAML to run jobs, and YAML stands for Yet Another Markup Language. Jobs contain series of steps or tasks. These can be things like copying the code from the repository onto the VM, building the application, publishing the application to a folder on the VM, and then deploying the code to a web server like Azure App Service. Each of those tasks could be accomplished by simply running a script or a command line instruction like the .NET command. Or the step could involve invoking a more complex, predefined component that's stored somewhere else. In GitHub, those components are called GitHub Actions, and in Azure Pipelines, they're called tasks. Both services provide many of these components for you, and they both have marketplaces where you can install third-party components. So besides building and deploying your code, you could include steps to perform static code analysis to ensure code quality, which produces a report or even a pass or fail score, depending on the component you use. When you define your workflows for either environment, you specify when you want the workflow triggered. That could be on a schedule, like performing builds overnight, but more likely, you set up continuous integration. So the workflow is started every time code is checked into a particular branch of the code repository. That way you can run tests and detect conflicts, so you can know if there's a problem with new code. You might also run tasks to deploy the code during that time, so you can see there are a lot of similarities in what these services can do. Of course, the implementation and screens are different, and even the flavors of the YAML language are a little bit different too, because they did originate from different companies, even though they're both now owned by Microsoft. I won't go into a lot of detail on all the capabilities of GitHub Actions or Azure DevOps, because there are many other courses in the Pluralsight library focused on both topics. I have several courses that focus on DevOps, including DevOps with GitHub and Azure, implementing CI/CD with GitHub Actions. That's a deep dive into GitHub Actions, if you're interested in learning more. So in this module, we're going to create a remote repository in GitHub and push our code up to it. Then I'll show you an easy way to configure a GitHub Actions workflow by letting AppService create it for you. Then we'll push an update to the GitHub repo and let GitHub Actions deploy our code to a deployment slot in AppService. Then we'll swap deployment slots in the AppService to promote the code to production. Next, we'll look at Azure DevOps. We'll create an Azure DevOps repo and push code into it. Then, I'll show you 2 ways to deploy the app from Azure repos to an AppService. First, by configuring AppService to receive a webhook call every time code is updated in the repo. AppService will then pull the code in and build it using the Kudu service and deploy the app to the AppService. The other method of deployment allows for complete customization of the build and deployment process by creating an Azure pipeline in Azure DevOps, where you can add any task that you need. So let's get started by looking at GitHub Actions. Let's start by creating a GitHub repo to hold our code. I'll open a new browser tab and navigate to github.com. I already have an account, so I'll sign in with my username and password, which are cached in the browser. From the home page, you can create a new repository for your code project. I'll give this repo a name, and it doesn't need to be the same name as the project name in Visual Studio, but I'll use this. I'm going to leave the repo as public, so anyone on the internet can see it. But GitHub Actions is also free for public repositories. For private repositories, each account has a certain amount of free minutes and storage for use with GitHub Actions. So let's create this repository. Once it's ready, this is the URL that we'll need to configure in Visual Studio in order to push the code to GitHub. So let's copy it. And let's go back to Visual Studio and up to the Git menu. In the previous module, we added this project to a local Git repository and configured a remote repository in the Azure App Service, so we could push our code to Azure and have AppService build and deploy the code. So we need to remove that remote repository reference. I'll highlight this and click Remove. Now we can OK this and go back to the Git menu and select Push to Git Service. That opens this dialog where you could create the local repo if you haven't already. And you can actually create a repo in GitHub by first signing in. And we can also connect to an existing remote repo. Let's sign in from here though. A browser tab opens, and because I'm already logged into GitHub, the OAuth 2.0 authorization flow completes without me having to sign in. Let's go back to Visual Studio, and it says there's already a repo in my GitHub account called Deployment App. Because we're on the screen to create a new repo in GitHub, let's switch to the existing remote app. Now I can paste in the URL to the remote app that I copied to the clipboard, and click Push to push the code from the local repo on this VM into the remote repo in GitHub. Let's go back to the browser and to the GitHub tab and navigate to the code page. Now there's code here that was pushed up by Visual Studio. Let's navigate into the project folder. There's the CS_proj file and the www root folder. So this is the source code, not the publish files that you saw in the previous module. Remember, GitHub is a code repository, and GitHub can also build this code and deploy it to Azure App Service. But we do that using GitHub Actions. So let's configure a GitHub Actions workflow to do that in the next clip.